Okay, we continue with the next speaker. And we're happy to have with us Lida Guo, who is a senior strategy manager. And she also gives an outlook on PV module technologies and future trends from the view of JA Solar. Lida, I'm very happy to have you with us.
Yeah, thanks. Hello, Michael. Hello, everyone. So next, I'll share my screen. Wait a second. Can you see my slides now?
Yeah, very well.
Okay. So let's start. Hi, everyone. I'm Lida from JA Solar. I'm honored to be here with you today, and I will be talking about PV module technologies and future trend. There are three main parts in my presentation. First, I'd like to talk about solar cell technologies. Then I will introduce PV module technologies and future trend. And finally, I will show you the performance analysis of different PV modules. So first, let's start from part one, solar cell technologies. This slide gives us the best research cell efficiencies in the world. As we can see from here, there are many kinds of PV technologies, including silicon, solar cell technology, thin film, and so on. But in the industry, the mainstream technology is still the silicon solar cell technology. And the highest efficiency for P-type cell in the lab is 26.1%. And for N-type, it's 26.7%. Another emerging technology I'd like to mention is the perovskite and silicon tandem solar cell technology. The efficiency has been increasing really fast. Now you see here it's 32.5%. Several months ago, it was 29.8%. So very promising, but there are still some problems about this technology. For example, the stability issues. And next, in terms of mass production in the industry, in recent years, the efficiency of N-type cells, including TOPCon and HJT, has been increasing, and the cell efficiency is over 25% now. So the production capacity will be further expanded in the next 1 to 2 years. Regarding the tandem solar cell technology, the efficiency will possibly exceed 30% in the next 5 to 10 years in the industry. The picture on the right shows the solar cell efficiency roadmap of JA Solar. Now the efficiency of mass-produced P-type solar cell has reached 23.7%, and the efficiency of N-type cell is over 25%. In the year 2025, these two numbers are expected to reach 24% and 26% respectively. Besides, JA Solar also plans to develop HJT, back contact, and tandem solar cell technology. The efficiency of HJT and back contact cells will probably reach 26.5% and 27% respectively in 2025. And that of tandem solar cell may get to 29% in 2025. So besides the efficiency in the industry, you may also want to know, is there a limit for efficiency? The answer is yes. This slide gives us some theoretical limiting efficiencies. As can be seen here, the limiting efficiency of P-type PERC cell is 24.5%. As I just mentioned, now the average efficiency in the mass production has hit 23.7%, which is really close to this limit. So further improvement becomes difficult to achieve. Well, there are several main pathways for silicon cell technology beyond PERC. For example, HJT with limiting efficiency of 28.5 and bifacial TOPCon with upper limit efficiency of 28.7%. So with promising efficiency potential, N-type technologies, including TOPCon and HJT, will definitely play important roles in the future. As can be seen from the picture showing the market share prediction, in the next 3 years, the P-type PERC module will still be the mainstream PV product. At the same time, the proportion of N-type module, including TOPCon and HJT, will gradually increase and will possibly become the next mainstream technology after PERC. So that's all I want to say about solar cell technology. Next, let's now move on to the second part, PV module technology. This chart gives us the module power trend. We can see during the past decade, the leading module power has been increased from about 300 watts to over 600 watts. Since the year 2017, the power has been increasing much faster, especially in recent 2 to 3 years. The large size wafers have brought this big leap in module power. At the top of this picture, there are some factors contributing to the increasing module power. Specifically, the factors include improving cell efficiency, optimize module encapsulation, and application of larger wafer. So let's look at the efficiency first. Thanks to the application of PERC technology, the average efficiency of mass-produced silicon solar cell has increased from 17% in 2009 to 23.7% last year. Plus, the wafer quality has been improved and N-type technologies come, then we get even higher cell efficiency. In terms of module encapsulation, multiple advanced technologies and materials have been applied to achieve this higher module power, such as coating glass, high transmittance EVA, MBB, and also some high-density module encapsulation technology, like shingling, tiling ribbon, and paving. Regarding wafer size, we know it grows from 125 millimeter and then to 166 millimeter. And in the recent years, 210 millimeter was born, and after that, 182 millimeter wafer was launched. So next, let me elaborate on some of the main module technologies. The first one is the half-cut cell technology. By cutting these solar cells in half, the current within the cells is also halved. This reduces the internal resistive loss and thereby increasing module power and efficiency. In addition, the hot spot temperature is reduced by 10 to 20 degrees Celsius. Another advantage is that half-cell module has higher shade tolerance. Another mainstream module technology is multi-busbar technology. The MBB reduces resistive loss and shading losses by using thinner and more fingers and busbars for solar cells. For half-cut cell, the MBB generally refers to 9 to 12 busbars. And in the future, with the advancement of process and equipment, the MBB will develop to SMBB, which super multi-busbars, which adopts over 16 busbars. Besides the main technologies, I would also like to talk about the high-density technologies, because high density is an important development direction for module. The first one is shingle module. Here, solar cells are cut into 4 to 6 strips and interconnected using a electrically conductive adhesive. As can be seen from the picture on the right, the spacing between the adjacent cell is eliminated, and so more solar cells can be crammed into one module, thereby increasing the module power and efficiency. However, there are some disadvantages. For example, the cost increases significantly, and there are some long-term reliability risks for this module technology. Another high-density technology is tiling ribbon. Ribbon is used to realize the overlap connection between the solar cells, and this can also eliminate the gap between the solar cells, thereby improving the efficiency. Normally, flat ribbon can be used to deal with the mechanical stress at this cell connection, and round ribbon can also be used, but here the ribbon at the cell connection needs to be reshaped. However, there are still some technical process challenges. So the process of tiling ribbon still needs to be continuously optimized during future mass production. And the long-term reliability still needs to be further verified. So here comes the question: is there a high-density technology that can achieve both high efficiency and high reliability? The answer is yes. JA Solar has developed this GFI technology. The full name is Gapless Flexible Interconnection Technology. We have also filed related patents. Here we use round ribbon together with special cushion design to deal with the mechanical stress at the cell connection. And this will eliminate the micro crack problem for high density solar modules. And it can also remove the gaps between the solar cells. As a result, this high density technology improves the efficiency as well as the reliability. Based on some of the advanced technologies I just mentioned, JA Solar has developed the Deep Blue 3.0 module, which is our current core product. It is based on upgraded size using 182 millimeter wafer. Actually, this size was decided by considering the whole industry chain, including production, transportation, installation, and so on. And gallium doped wafer is used to reduce the degradation rate. Also, multi-busbar and half cell technology are applied to this product. The power of Deep Blue 3.0 is up to 595 watts for 78 cell module with efficiency up to 21.3%. We have designed modules with different sizes to fit with different PV applications. For example, the smaller module is designed for residential projects, while the larger ones are more suitable for utility scale products. Besides our core product, JA Solar also developed some high-end products. For example, our all-black PV modules. We have conducted excellent control of solar cell colors, so our all-black PV modules looks really good. They look like panels of color glass. We also have different size to fit on different roofs, so they are excellent choice for rooftop solar market. Another high-end product is our N-type module, Deep Blue 4.0X. There are several advantages. The highest efficiency is 22.4%, which is 1% higher than P-type module, and the power is up to 625 watts for 78 cell module. The second advantage is lower degradation. The first year degradation is less than 1%, and the annual degradation is less than 0.4%. Another merit is lower temperature coefficient of power. For N-type, it is only minus 0.3% per degree Celsius, which is much lower than that of most conventional modules at minus 0.35%. In addition, the bifaciality is higher than P-type module, reaching 80%. For P-type, it's only around 70%. Next, let's have a look at the product development of JA Solar. Deep Blue 3.0 was launched in 2020, and then Deep Blue 3.0 Pro was born in 2021. And in last year, we have our new N-Type 4.0X, and all the way the technology, efficiency, and power have been consistently improved. This year, we will launch new products based on other N-type technologies, for example, AGT technology, and we plan to establish gigawatt level production line by the end of this year. So please stay tuned for our new product launch, which is coming soon. Now you've heard a bit about the PV module technologies. Next, let's move to the third part, performance analysis. Based on same solar module efficiency, large module with higher powers will significantly reduce BOS costs, as can be seen in this picture. However, the downtrend of BOS becomes less obvious when the module size increases to a certain level. If we continue to increase the module size, it will bring some risks. For example, it is easier for larger module to fail the mechanical load test and hill test. And the larger module brings difficulties in transportation and installation. Another thing we need to consider is the rack bearing ability, especially in some regions with high wind speed. Therefore, improving power through larger panel will be valueless. In the future, the trend shall be improvement of solar cell and module efficiencies. Next, I'd like to show you some data from our demonstration project. We compared the performance of P-type and N-type Deep Blue 4.0X module. The data shows the power yield of N-type module is 3.9% higher than that of P-type module, which is the blue one. We also made some simulations of a 100 megawatt projects in Dubai to compare the BOS and LCOE of Deep Blue 4.0X and P-type module. The BOS for N-type module is 2.1% lower and LCOE is reduced by 4.6%. We believe as the cost of N-type module gradually decrease, it will become very competitive in the PV market. In the future, JA Solar will continue to provide customers with PV products with the best LCOE and highest customer value. So that's all I want to share today. Thanks for your attention.
Thank you, Lida. Very nice. I think that was a wonderful overview, leading us through what has been happening in solar recently and what's to be expected. I think what was also very interesting that you shared your cell efficiency roadmap. As I understand, you're at 23.7% cell efficiency for PERC. Is this the best or is this the average efficiency at the moment?
Yeah, that is our current average efficiency in mass production line.
Okay, okay. And for the 25% you show is for TOPCon, also the average efficiency?
No, actually, it's our best R&D efficiency. It's over 25%. For mass production, it's around 25%.
Okay, okay. Interesting. It's interesting that you also plan to make, I think for TOPCon quite some, so I think in the first half year of 2023 that you really think about making quite a jump of 0.3% to 25.3%. So that means this will be the new products coming out with 25.3% then, or will that be new products, or will this be simply improved and you add another efficiency class?
Sorry, could you please?
Yeah, for your TOPCon products, you say in your roadmap you wanna reach 25.3% cell efficiency in the first half of this year. Will there be new products out there, or will there be just a higher power class then available for your products?
Yeah, we will have some special designs for our product to further improve the efficiency, cell efficiency and module efficiency. But the strategy is not totally confirmed yet.
Okay, and then I think it was interesting because you also mentioned that you mentioned HJT actually. What's your current capacity for the different technology, and what's your plans also, because you said you are coming out with heterojunction technology soon?
Now we just have a pilot line of HJT, but we have a plan to build a gigawatt level production line by the end of this year for HJT. For our current Deep Blue 4.0X, we will have 27 gigawatt at the end of this year.
Okay, very interesting. I think there is a couple of questions in the chat. If you have time, it would be nice if you could answer them as much.
Sure.
Okay, Lida, thanks so much. Have a nice evening.
Thank you. Bye.
Bye.